Chapter 3, Stonehenge Phase 2. The Avenue. When the waters started to subside, the builders of Stonehenge had an engineering problem: how to cope with the lower groundwater table, to allow the Stonehenge moat to remain full. Firstly, as we have already illustrated, by lining the Stonehenge moat with a clay waterproofing, so it acted like a dew pond, and in this chapter we shall go into detail of how they built a new earthwork called the Avenue with its own moat, which brought the waters closer to the monument's bathing moat. Processional walkway. The Avenue was created sometime after the original moated henge, once the original Mesolithic groundwater and shoreline lowered towards the new Neolithic groundwater level. When the water levels fell, the builders faced two problems. Firstly, the original mooring could no longer accept boats or cargo, so a new entrance was required. Secondly, the moat would no longer fill as it did in Mesolithic times, as the water table had dropped by about 10 meters. As we have seen from the excavations by Hawley in the 1920s, the builders had added a liner similar to those found in other Mesolithic period constructions like dew ponds also found in this area. The reason for the liner would have been to retain the water that accumulated by the natural rain and seasonal high tides that would have replenished the moat. It is entirely plausible that insufficient, or infrequently water levels were a common occurrence during the late Mesolithic, therefore if they wished to continue the bluestone treatments, an alternative method to fill the moat needed to be found. The Avenue is quite curious, and excavations have revealed its ongoing development, as indicated by the post holes dotted down its entire length. This clearly shows that it adapted over a long period to match the retreating shoreline in the Neolithic period, which lasted over 2,500 years. Moreover, the physical construction of the Avenue earthwork shows the incorporation of water features. The southern ditch is much shallower than the northern ditch of the Avenue. This is because the water lies on the southern side of the Avenue and does not need extra depth to fill the southern ditch evenly, while the northern ditch is further away from the water, and on a gradient. For it to fill evenly to the same depth of water as the southern ditch, the northern ditch would therefore need to be 10% deeper. Furthermore, this extra depth to one side of the monument can also be seen in the main ditch of Stonehenge, as the main ditch corresponding to the northern Avenue ditch is also 10% deeper. Further evidence of this shoreline can be seen in the post holes found in the Avenue. These post holes do not make sense, as they would have blocked the walkway unless they are mooring posts for various phases in the Avenue's construction and water level. A small survey carried out from 1988 to 1990 investigated the last 100 meters of the Avenue up to the elbow. It found 14 large post holes that could have been used as moorings for boats. These moorings are paired off at 45 degrees to the Avenue, which would match the exact shoreline predicted over several periods. Recent investigations have revealed that as well as post holes down the Avenue, there is a distinctive man-made mound of clay and flint called Newell's Mount, named after its discoverer, and a second mount can also be found on the contour maps of the Avenue, but has yet to be named or excavated, which has the same characteristics and post hole alignment. This indicates that these human-made mounds were used as raised platforms to unload boats, as they could not serve any other practical purpose. Sarsen stones. The Sarsen stones would have been brought to the Stonehenge site before the river disappeared from Stonehenge Bottom to become the River Avon of today. The reason why our ancestors used Sarsen stones is fascinating, as the original structure, which consisted of Welsh blue stones, lasted over 4,000 years as a centre for curing sickness. Clearly, they had a requirement for a very large monument built of a different stone. From an engineering point of view, the size and structure were significant, and because of the size of these stones, the most effective means of transportation to this site would again be by boat. Even though the deeply forested landscape would have started to thin, the subsoils would still have been waterlogged and marshy after the groundwater had receded, making it impossible to drag heavy stones across large distances. The construction of the Sarsen monument is of even greater interest, because if they were building only for aesthetic pleasure, then you would imagine that simply laying one giant stone on top of another would be sufficient, as seen at other megalithic sites. But our ancestors wanted to do something special with these stones, so they carved mortise and tenon joints on their surfaces. The only engineering reason for this method of construction would be that they required this site to last for a considerable time in history and hence its importance to this civilization. The exact date of this process may never be fully known, for we have yet to excavate fully and carbon date the post holes in the avenue similar to those in the car park at Stonehenge, which would give us an accurate date. But we still have a few clues to provide us with an approximate date, as we know that the river must yet have been present at the end of the avenue for the unloading of these stones to take place. And it must have been after the groundwater left the northwest shoreline, but before the groundwater reached the elbow. Let's consider the reason behind the construction of the avenue. It clearly follows a path to the river, but the river reached all the way to the east of the site in Neolithic times, and therefore, in theory, the avenue could have been built anywhere. So why did they build it in that particular direction? The northwest entrance is oriented quite deliberately towards the midwinter moonset, perceived as the place of the dead and afterlife. After 4,000 years, is it possible that the monument changed its purpose? If so, perhaps they decided to use the trusted waters of the past still, but change it from curing the sick to celebrating life and rebirth through the sun. This may explain why the avenue was oriented to the summer sunrise and, this being the case, give us our third clue to the date the site was built. We are familiar with the masses that welcome the midsummer sunrise over Stonehenge. People wait in expectation, then, if you're lucky, the sun creeps over the heel stone to welcome another day, everyone's happy and goes home drunk. When you look at the heel stone, it is on the extreme right-hand side of the avenue, bent over at a silly angle. Our ancestors did not build it that way. The monument was very nearly completely rebuilt at the end of the last century, and stones were moved, and this process happened throughout Stonehenge's history. The most sensible alignment is straight down the middle of the avenue. This is apparent alignment has only been partially investigated and as a result questions the traditional dating of the site. The sun does not always rise and set in the same place in history as you may expect. The Earth wobbles on its axis in a process known as precession. I will not go into detail here, but all you need to understand is that the sun and moon rises and sets in a different location over a 43,000-year period. This means that the summer and winter solstice moves in relation to the horizon a fraction every year. This movement is tiny, it's 0.0002 of a degree every year, but over a long time, say 10,000 years, it's a full 2 degrees. It may not sound much, but when you consider that the moon is half a degree in diameter, then 2 degrees is the same as 4 moons, or suns, in a row on the horizon. We can also reverse engineer this figure to give us a date for the construction of the avenue. The problem with this measurement is that the point of sunrise is somewhat subjective, as the horizon is obscured with trees at Stonehenge, so the tip of the first sunlight can never be fully seen. What current observers accept is the position of the heel stone, which obscures the sunrise until a point that it appears to rise above the stone's upper part, the peak point. If we accept that this is the correct solstice sunrise point for today and plot this point on Google Earth, we obtain a reading of 50.81 degrees. If we now take a reading down the center of the avenue with the same software, we get a reading of 49.57 degrees. This is a difference of 1.24 degrees since the avenue was constructed. If each year the sun moves 0.0002 degrees per annum, then we will have an approximate date, when the sun is at the center of the avenue. This gives us a construction date of 6,200 years ago, or 4180 BCE. Moreover, to support this dating, there is one antler bone that was found under a sarsen stone, which doesn't support the current dating. Now this one can't be explained away like the others, as a 12-ton stone was on top of it for thousands of years, guaranteeing that it could not have been placed there at a later date, or floated there from another part of the site. It was found in the packing for sarsen stone 27, OXA 4902. This gives us a carbon dating of 4,342 to 4,039 or 4191 BCE plus or minus 152 years, which is remarkably similar to the avenue dating method. Therefore, I am happy to conclude that Stonehenge Phase 2 started around 4185 BCE. Monument to the dead. The most popular view of Stonehenge is of a completely round monument with lintel stones completing the circle, but there is a massive problem with this idea, for not all the stones or the stone holes are present. Some people have suggested that the monument is incomplete, but those individuals do not understand its significance or the reason behind the construction. A monument to the dead, as we have previously illustrated, would not face the summer solstice sunrise. It would either face the moon's furthest setting in the night sky, the northwest and the lost Mesolithic pathway, or it would face winter solstice sunset to mark the shortest day, when light finally overcomes the darkness, the symbolism of rebirth, life after death. Another reason to ignore the reference to a solar temple is that the sun is usually represented as life and a circular symbol, as we see in many ancient civilizations in the Middle East and South and Central America, where monuments to the dead are represented by the moon, and particularly a crescent moon. Stonehenge was designed to be crescent-shaped, with an alignment to the winter solstice sunset, and hence the construction and alignment with a trilithon, two standing stones with a third suspended on top of the two uprights, in the southwest quadrant, which only one survives and is still upright, which is not surprising, as the Druids in the Iron Age altered the monument symbology by pulling the heel stone to an awkward angle to meet the sunrise of the summer solstice, and no doubt pulled down the trilithon in the southwest quadrant. The crescent within the crescent, the larger horseshoe trilithon standing stones, that faces the summer solstice sunrise, this is very symbolic as it represents rebirth or reincarnation. It's a poignant message through the ages to us, the descendants of this civilization, that their homeland may be dead, but the survivors still live on, to begin again. This can be proven in various ways. In archaeological terms, the fact that the stones are missing is a problem for archaeologists, unless the monument was incomplete. All the so-called missing stones of the monument are in the southwest quadrant. This area is the furthest away from any roads. If you are going to cart away stones, would you not start at a point nearest a road, rather than the stones furthest away? The second problem with the solar temple is that some of the existing stones that have not been moved or chipped away are not large enough to take a horizontal lintel stone, such as stone 11. Consequently, the only type of monument that the site could have been designed for is the crescent moon facing the winter's solstice sunset. Slaughter stone. In the center of the Sarsen circle lays an extraordinary stone, the altar stone. The reason it's unique is twofold. Firstly, it's made of material, unlike the other Sarsen standing stones, called mica. Hawkins makes note that while all the other stones were either bluestone or sarsen, the so-called altar stone is a fine-grained pale green sandstone, containing so many flakes of mica that its surface, wherever freshly exposed, shows the typical mica glitter. The second reason is that it was positioned to be flat to the landscape. The only other stone that was designed in that fashion is the slaughter stone. Most archaeologists believe that the slaughter stone was once a standing stone at the entrance of the monument. These are flawed theories, and a result of a hypothetical drawing by Inigo Jones in 1655. This drawing shows Stonehenge as a perfect circle, Roman solar temple, with hexagon-shaped trilithon and 3 entrances into the site with 6 erect standing stones as access points, which the slaughter stone was one. This idea was incorporated in John Aubrey's drawing in 1666, which was more accurate, but again had the tendency to place all the fallen stones in upright positions. Yet the myths among archaeologists still remain. The reality is that the slaughter stone was always, like the altar stone, a deliberate recumbent, as the excavations of this stone by Hawley and Newell in the 1920s clearly show, as the chalk subsoil was also deliberately flattened before it was placed in its current position. Hawley presumed that the slaughter stone was once buried. This idea is understandable as the stone does lay below the ground level, but what Hawley never understood is that the reason the stone was in this position was for the same reason the ditch was built around Stonehenge, as it was made to be full of water. This can be observed by the size of the stone hole called EWA 1165, which lays 2 meters, northwest of the slaughter stone, but still within the hollow that also contains the stone. Most stone holes at Stonehenge are relatively shallow, less than a meter in depth, but stone hole E is twice as deep, over 2 meters. If the slaughter stone was placed in it, as the experts some have suggested, it would only be 3 meters high on the surface, compared to 4.57 meters for the heel stone a few yards away. The only other place in Stonehenge with these more massive pits are within the ditch section that surrounds the site, which is the same depth, allowing access to the groundwater levels. In the past, when the slaughter stone was placed in this ditch, like the moat, water would have surrounded the stone like an island. Therefore, what we see today at Stonehenge is a 6,000-year-old relief map of the land the megalithic builders originated from, Doggerland, which now lays below the North Sea. Not only did they place a 6-foot piece of sarsen stone, flat in a watery ditch, but they also carved out the contours of the island, showing high and low ground, like a contour relief map. Archaeologists have always believed these features were weather-worn by age, although the other recumbent stones have not been weathered in the same fashion, but recent laser technology has confirmed our belief that this stone was actually carved, as the markings from the tools used, and can still be seen at microscopic levels. Moreover, and more importantly, the stone has been placed in a bizarre position, almost in the way of the avenue. This shows that this stone and the avenue have a connection. This type of relationship we see in association with Egyptian pyramids, when sight lines are cut into the sides of the burial chambers to important star constellations to show their associations with the gods. At Stonehenge, the slaughter stone and the avenue are important as they link rebirth with the death of this great civilization, for if we look from the altar stone pasted the slaughter stone, they make a sightline, which quite remarkably points directly to Doggerland, as it was located as a small island at the time of the avenue's construction in 4100 BCE. Geologists currently estimate the sinking of Doggerland as 2,000 years earlier at 6200 BCE, as they have found a tsunami that would have hit the island at that point in history. Yet, as we have seen in the Indian Ocean and Japan, when tsunamis hit, they do not sink the region. Sadly, this is just another example of bad science. This is confirmed with a bit of simple maths, as we know that the island is between 15 meters to 36 meters, average 25 meters, under the sea as a sandbank, and hence covered in modern-day wind farms. And we know, from satellites, that the sea rises 3.6 millimeters per annum. Consequently, by 4100 BCE it was still 6 meters above sea level, but probably so small it was uninhabitable. Let's recap what we have learned in this chapter. 13. The avenue ditch on the northern side is 10% deeper than the southern side. This variation also happens where the avenue ditch meets the main Stonehenge moat. This is proof that the ditches were dug to find the water table at the time of construction. 14. The avenue initially terminated at Stonehenge Bottom, where the water table level dropped in the Neolithic period. This is proven by the existence of both post holes and 2 loading platforms towards the end of the avenue, which coincided with the past river shorelines. 16. The slaughter stone was deliberately buried into the chalk bedrock, and hole WA1165 was dug 2 meters deep to tap into the groundwater and flood the ditch surrounding the stone, to create a feature of an island surrounded by water. This proves that groundwater remained even during the Neolithic period around Stonehenge.